Okay, so in this week's lesson, we're going to go back to 4.9, semester 1 material, and it's going to be a new lesson. I mean, we finished up most of chapter 4, but we didn't cover 4.9. And specifically, I wanted to go over solving quadratic inequalities with you guys, because there's a section in your homework, and you'll see in the worksheet, that actually requires you, I think for the most part, to use this technique. And so let me just go over some examples over here to teach you how to solve quadratic inequalities. Okay, so there's two ways. I will say off the bat that way 2 is a little bit easier because you just have to sketch. And this one's a little bit more tedious, but you always get the right answer. Okay, so the procedure here to solve a quadratic inequality algebraically is to get all the terms on one side and 0 on the other. Change temporarily the inequality to an equal sign, and then you solve for the x-intercepts. And test all the numbers on the number line, all values of x, which the inequality is true. And what I mean by test on the number line, test the x-intercepts on the number line, okay? And then way 2, graphically, I will go over this. Step 1 and 2 are basically the same, except in step number 3, you sketch and determine graphically all values of x for which the inequality is true. Okay, so let's take a look at this process right here for this first example. Okay, so solve algebraically. The first step, we're supposed to get all the terms on one side and 0 on the other. So let's do that. And step number 2, change temporarily the inequality sign to an equal sign. So right now I have an inequality sign, right? So I'm temporarily going to change it to an equal sign. And then I have a quadratic equation. It says solve for the x-intercepts. Okay, so basically I need to solve for what x is, or find the solutions to this equation. Right, if this was y, right, y is equal to 0, I'm getting the x-intercepts. And you can use all the techniques you've learned, right, solving by factoring, quadratic formula, completing the square. Obviously, if you look at this, right, factoring would probably be the easiest method, right? So let's solve by factoring. This would be x plus 8 times x minus 4. Okay, so you're going to get two numbers, negative 8 and 4. Those are your critical numbers, okay? So we'll call these the critical numbers. Critical numbers, or you can think of them as the x-intercepts, okay? So actually, call them x-intercepts because that makes more sense, something you learned before. So step number 3 says test those numbers. So we'll say test x-intercepts, okay, on the number line. And we're trying to find all values of x for which the inequality is true. And find all values of x for which the inequality is true. So what do you mean by that? So right now, in my number line, I have negative 8 and I have 4. Okay? So on the bottom of this number line, you want to test x values. And the top of the number line right here, we'll call it f of x, basically your y values. And what I'm trying to do, right, is to go back to this inequality right here. This quadratic expression right here basically is my f of x, right? This is f of x, this is my function. And if you think about it, right, this is basically saying find all values of x st, okay, such that f of x is greater than 0. Okay, so I want to see f of x basically is my y value, but I want to find all values of x such that my y is positive. Okay, so really on negative 8 and 4, because this inequality symbol does not have an equal sign, I'm going to put an open circle here, and all I'm going to do is test numbers to the left of negative 8, between negative 8 and 4, and then greater than 4, okay? And I want to figure out what the sign is. Is it positive or negative for my f of x? Positive or negative, positive or negative. but my solution set is where all values of x such that f of x is greater than 0. Another way of saying greater than 0 is positive. Okay, so a number to the left of -8, maybe try -9. And where am I plugging in -9? I would plug it into this expression right here. So just doing some mental math, right? You're going to have positive 81 minus 36. 81 minus 36, right? What is that? That's, 45, right? 45 minus 32. That's going to be a positive number. So all I care about is the sign, not the actual number. Okay, so I don't really care about what's 45 minus 32. That's 13, right? I only care it's positive 13. So any x value to the left of -8 will yield a positive y value. Okay, so that's basically what's going on. Now between -8 and 4, right, an easy number to plug in would just be 0. Right? If you plug in 0 into this expression, right, 0 plus 0, that's 0. 0 minus 32 is -32. The sign, the y value sign, is going to be negative. Okay, and then one more number, right, plug in maybe 5 over here. A number to the right of 4 is 5. And if I plug it in here, 25 plus 20, that's 45. 45 minus 32 is going to give me a positive number. Okay, so now that I've tested my x values, right, I want to find all x values such that f of x is positive. So what is my solution set? My solution set is right here and right here, right? And so if you want to sketch it right here on the number line, this is your solution set. And you would write x is less than -8 or x is greater than 4, right? And what does this mean? It means that every number to the left of -8, right, will yield a positive y value, which is what we want here. Every number to the right of 4 will yield a positive y value, right? We want to find all x values such that f of x is positive. F of x is positive for x is greater than 4. F of x is positive for x is less than -8. Okay, so that's pretty much to solving a quadratic inequality algebraically. Let's do another example if you didn't quite get that first one. So same process over here, right? This time the only thing that's different is that it's less than or equal to. If you try to solve for the x-intercepts on this one, I believe you're going to have to use the quadratic formula. Okay, so again, step number 1, move all the terms to one side, right? Change temporarily inequality to an equal sign. So let's temporarily change our less than or equal to 0 sign to an equal 0. And if you kind of play around with these numbers, right, you're not going to be able to solve by factoring. And factoring doesn't work. You can use completing the square, or you can use the quadratic formula. Okay, so for this one, I'm going to use the quadratic formula. Okay, x is equal to -b plus or minus square root 4 squared minus 4 times a times c all over 2a Okay, it looks like you're going to get 16 right here, minus 8 times minus 3 is positive 24. And you can see that the quadratic formula, while it always works, it's just a little bit tedious, right? You have to plug in and simplify radicals. Okay, so 24 plus 16 is 40. Okay, so you can simplify this if you want, right? Square root of 40 is 4 times 10, which is 2 root 10. And you can even simplify this even further if you want. So if we factor out a 2 over here, between these two terms, right, you can only cancel out factors. This will become a 1, this will become a 2. Okay, so over here, you're going to get negative 2 plus the square root of 10 over 2, or x is equal to negative 2 minus the square root of 10 over 2. Okay, so if you take a calculator, I believe the answers in your textbook are all going to be approximate. You enter negative 2 plus root 10 over 2. Let's see what we get here. Okay, you're going to get about 0.58. And over here, you're going to get approximately, I believe, negative 2.58. All right, so we got the x-intercepts, okay? So this is just a little review of, solving quadratic equations, right? Now, what's step number 2 after you got the x-intercepts? You test these x-intercepts on the number line and you find all values of x for which the inequality is true. So this is where I draw my number line over here. Smaller number on the left, bigger number on the right. Now this time when I write my inequality at these actual numbers, for the circles, I draw a closed circle, right? Because it can actually equal, right? So this inequality has an equal sign here. So instead of drawing an open circle, I have an equal circle. And you do the exact same process, except this time, right? What I would do is go back to this original problem, call this f of x, right? This is a function. And what is this inequality really asking me? It's saying, find all values of x, right? We want all values of x such that, right, f of x is less than or equal to 0. That's basically what this inequality is saying when you're solving a quadratic inequality, okay? So I want to find all the x values where the y value is less than or equal to 0. In other words, where the y value is negative. So, just like we did on the previous problem, right? Call this x, call this f of x, and start testing numbers to the left of negative 2.58, between negative 2.58 and 0.58, and then numbers greater than 0.58. Okay, so a number to the left of negative 2.58 would be negative 3. And if I plug in negative 3, where do I plug it in? I'm going to plug it into the original inequality where it has all the terms on one side and 0 on the other side. Okay. So if I plug in negative 3, let's see if we can do some mental math here. That's 9. Negative 3 squared is 9. 9 times 2 is 18. 18 minus 12, that's 6. 6 minus 3 is just 3. So right here, this is going to be a positive number. Let's say if I plug in 0, 0 plus 0, that's 0. 0 minus negative 3, that's a negative 3. So that's a negative number. And lastly, if I plug in a number to the right of 0.58, let's say I plug in 1. 1 times 2, that's 2. 2 plus 4, that's 6. 6 minus 3, that's positive 3. Okay, so that's going to be positive. All right, so is the answer going to be right here, right here? Well, no, this time it's saying find all x values such that f of x is less than or equal to 0. So I want to see where y is negative. Well, y is negative right here, right? So all the x values will be numbers between 0.58 and negative 2.58, right? It's in this region. So this is my solution set. So I would write x is greater than or equal to 0.58, but less than or equal to, or sorry, greater than or equal to negative 2.58, but less than or equal to 0.58. Okay, so that's how you solve these problems algebraically. It's a little bit tedious in my opinion because I will show you in way 2. It's a little bit easier to solve graphically. All right, so we're going to move on to that technique, which is going to be introduced here. Okay, so we're going to solve graphically. And does it mean I have to graph it? No, it just means you can sketch it. Okay, so you don't have to, draw the vertex and everything. So I'll just say solve graphically just means sketch. Okay, so the technique is pretty much the same for steps 1 and 2. What you want to do is get all the terms on one side, change temporarily the inequality to an equal sign, and solve for the x-intercepts. The only thing that differs in step number 3 is, right, you want to sketch and determine graphically all values for x for which the inequality is true. Okay, so first things first, right, move that term over. And this looks like it's a nice factorable quadratic equation. So let's change the inequality symbol to an equal sign. and solve by factoring. So over here we have 2x and x, and it looks like we could write 2 over here, right? I want to get 1 here in the middle. Sorry, I want to get 3 here. So this one's right here is going to be 1, right? But I want it to be a positive 3, so I'm going to call this plus 2 and minus 1, right? Negative 1x, positive 4x will give you 3x here in the middle. Okay, so quickly set this equal to 0, right? 2x minus 1 is equal to 0. You're going to get x is equal to 1/2. And of course, if you set this equal to 0, you're going to get x is equal to negative 2. All right, so these are my x-intercepts, right? So I already did step 1. I already did step 2, right? The same. This is using solving by graph. And now I have to sketch and determine graphically all values of x which the inequality is true. So if you remember algebraically, right, I had to test these on the number line. It gets a little bit tedious, not difficult, but it's very easy to make a mistake. So let's go back to the question of what does it mean to solve a quadratic inequality? This means find all values of x such that, right, call this your f of x, is less than or equal to 0. That's what this problem is asking you to do, okay? And, you know, remember back in semester 1, I taught you how to graph this, right, by finding the vertex. Well, you don't need to be super precise in finding the vertex. You just need to sketch it and know if the parabola is going up or down, okay? So I know that since a is positive, right, in this problem, the parabola is going to go up. And I already have my 2 x-intercepts. So let's do a quick sketch, okay, of this particular problem. I have an x-intercept at negative 2, x-intercept of 1/2, right? And these guys are closed circles, right, because there's an equal sign here. And the parabola is going to go up, right, because a is positive. So it's going to go up. Okay, so this time you don't have to test anything on the number line. If you think about it, right, I want to find all values of x such that f of x is less than or equal to 0. So take a look at your graph, right? F of x, if I ask you, to the left of negative 2, right, the y value, is it positive or negative? Clearly the y value is positive, right? Positive, 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 right? Now, once I go past negative 2, going this direction, right, the y value of the graph is negative, 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 right? And then once I go past 1/2, the y value goes positive, positive, right? So what was the question again? Find all the values of x such that f of x is less than or equal to 0. Well, f of x is less than or equal to 0 between 1/2 and negative 2, right? This is the solution set. So your final answer is x is less than or equal to 1/2, greater than or equal to negative 2. And you see that this problem does not require any testing of points, long as you're able to see graphically that the y value is less than or equal to 0, right, for x is between negative 2 and positive 1/2. Okay, so this is what I mean by sketching is a lot easier. Let's do one more example in case that didn't quite make sense. So same exact process, right? Move your 5x over. This becomes 0, right? And I believe this one is also going to be factorable. Okay, so change it to an equal sign temporarily. And this will be plus 2 plus 1. Okay, so this will be 1x, right, plus 4x. That gives you the middle term, which is 5x. So real quickly, right, you're going to get x is equal to negative 1/2 on this one. X is equal to negative 2. And same exact process, right? The parabola right here, what is this question asking? This is saying, this quadratic inequality is saying, what are x values such that f of x, right, this whole thing, call it f of x, is greater than 0, right? I want to find where my f of x is positive. Okay, so x-intercept at negative 1/2, x-intercept at negative 2. And actually, I'm going to go over here. And if I ask you, is this parabola going up or down? You would say, hey, the parabola is going up, right, because a is positive. You don't need to worry about the vertex or anything. This is just a sketch. This time at negative 2 and 1/2, and negative 1/2, it's an open circle, right? Why? Because there's no equal sign here, okay? So it's an open circle. And I just look at my graph, right? The y value is positive here. The y value is negative here, right? Until it goes past 1/2, right? To the right of negative 1/2, the y value is going to be positive. Okay? So someone might ask, well, you had two examples where the parabola is going up. What if you decide to move these terms over? In which case you get negative 2x squared minus 5x minus 2. Then you would say, what are the x values such that f of x is less than or equal to 0? But these values are going to slightly change. Your answer won't change. Okay? All right, so back to the original question. What are the x values such that f of x is positive? Well, f of x is positive when x is greater than negative 1/2, right? So this is the solution set. And f of x, my y value, is positive to the right, right? If I go this direction, to the right of negative 2, to the left of negative 2, right? The y value clearly is positive. So how would you write the solution? You would say x is less than negative 2, or x is greater than negative 1/2. Okay, so hopefully this makes more sense. If it doesn't, try to look at some of the examples in the textbook, or just rewatch these videos until it makes sense. Or you can always email me if you need help.